Welcome to today's Explainer. We're jumping right into one of the most catastrophic, literally earth-shattering events in our planet's history, the sudden wipeout of Earth's apex predators. We're going to trace the epic rise of the dinosaurs, break down the unfathomable disaster that ended their reign, and look at what the latest data tells us about our own future here on Earth. Let's get into it. 174 million. Just let that number sink in for a second. For 174 million years, these terrifying absolute giants ruled our planet completely unchallenged. I mean, they weathered massive climate shifts, they survived continents literally breaking apart, and they adapted to entirely new ecosystems. They were the ultimate survivors. That is, until one single day changed Earth forever.
The era of dinosaurs. Okay, before we can truly grasp how they were destroyed, we really need to understand how completely they dominated the globe.
You know, our understanding of these creatures has evolved so much over time. The actual word dinosaur didn't even exist until 1841. It was coined by a British scientist named Richard Owen, who combined the Greek words dinios, meaning terrible, and sauros, meaning lizard, a terrible lizard. And it's pretty funny when you look back, because early drawings of fossils looked completely different from the highly accurate bird-like depictions we have today. Paleontologists have now unearthed over 10,000 fossils worldwide, and incredibly, we're still discovering an average of 45 new species every single year.
Now, this empire didn't just pop up overnight. It was built across an unimaginably massive timeline. Back during the dry, arid Triassic period, Earth actually went through a huge global warming extinction event. It was driven by volcanic eruptions that split the supercontinent Pangaea wide open. Most cold-blooded reptiles perished, but the warm-blooded dinosaurs, they survived. And that specific survival catapulted them into absolute dominance throughout the Jurassic period and ultimately straight into the Cretaceous period. The Cretaceous period was, without a doubt, the absolute peak of dinosaur prosperity. The continents were finally shifting into shapes we might actually recognize on a map today. The climate was beautifully warm, sea levels were high, and the world saw its very first flowering plants, though fun fact, grass hadn't actually evolved yet. This perfect, lush environment allowed for the rise of just unimaginable beasts. We're talking 77-ton herbivores like the Argentinosaurus, and of course apex predators like the 40-foot T-Rex, packing jaws that could crush solid bone in an instant. Essentially, Earth was lulled into a false sense of security.
I want to pause on this timescale comparison because it absolutely blew my mind. Humans, you and me, are actually closer in time to the existence of the T-Rex than the T-Rex is to the Jurassic period. We're separated from the T-Rex by about 68 million years, but the T-Rex is separated from the end of the Jurassic by 80 million years. So yeah, despite what all those famous movie logos might tell you, the T-Rex didn't even exist in the Jurassic period. It evolved at the very tail end of the Cretaceous. It really puts into perspective just how unimaginably long their era lasted. The 66 million year asteroid. So, picture this. Everything's perfect. Life is flourishing. And then, why does it all end? Well, due to nothing more than the random, unavoidable orbital mechanics of our solar system. Earth's path just happened to intersect with a massive rock from space, roughly 10 to 15 kilometers wide. Wrong place, wrong time.
And this asteroid wasn't just drifting. It was traveling at a terrifying 30 kilometers per second. To give you some real-world context for that number, that is 150 times faster than a commercial jet airliner. The animals on the ground wouldn't have even had time to process what was happening. Zero warning.
When it finally struck the Yucatan Peninsula in modern-day Mexico, the energy released was, frankly, beyond human comprehension. If we use the horrific atomic bombs dropped on Hiroshima and Nagasaki as a baseline, the energy unleashed by this single asteroid strike was 1 billion times greater. We're talking about the equivalent of 100 teratons of TNT. Everything within thousands of kilometers was instantly disintegrated or cooked alive by the sheer heat of the blast.
The deadly global aftermath. But here's the thing. The initial blast, as apocalyptic as it was really just the opening act. You had massive shockwaves, global wildfires, and mind-boggling tsunamis with waves up to 2 kilometers tall. But it wasn't the blast or the waves that wiped out the dinosaurs on the opposite side of the planet. It was the long game, the deadly long-term consequences.
The impact triggered this grim, totally inescapable chain reaction. It threw millions of tons of pulverized rock, hot dust, and soil right up into the atmosphere, which completely blocked out the sun globally. The planet was instantly plunged into a nuclear winter. Global temperatures plummeted to freezing for about 3 solid years. And without sunlight, photosynthesis stops entirely. The plants died off. With no plants, the massive hungry herbivores starved to death. And once the herbivores were gone, the giant carnivorous predators ran out of food and they starved too. It was like a giant tragic set of dominoes. Ultimately, not a single terrestrial animal weighing over 25 kilograms survived this. The only ones to make it out alive were small scavengers like birds, a few reptiles, and our ancestors, early mammals.
Finding the evidence. Now, you might be asking yourself right about now, how in the world do scientists know all of this? How do we pinpoint the exact date and the precise location of something that happened 66 million years ago?
Well, the answer is quite literally buried in the dirt. Geologists found a very specific layer of a mineral called iridium spread out globally in the Earth's rock formations. Here's the catch. Iridium is incredibly rare naturally on Earth, but it's super abundant out in space, specifically inside comets and asteroids. When scientists carbon dated this global iridium layer, it pointed to exactly 66 million years ago. The asteroid effectively left a giant, undeniable blanket of space dust over the entire planet, giving us our definitive timeline.
And the physical scars? They are still here today if you know where to look. Down in Mexico's Yucatan Peninsula, there is a staggering crater 180 kilometers wide. Over the last 66 million years, tectonic plates have shifted around. So today, half of that crater is submerged under the ocean, and the other half is sitting right on land. But you can literally trace the exact rim of this ancient impact zone by looking at the famous cenotes. These are those beautiful natural sinkholes you see in travel photos. They form a perfect, continuous ring right around the crater's edge, actually creating the world's largest underground cave system. It's wild.
The sixth mass extinction. You see, the end of the Cretaceous period paved the way for the Paleogene period. The extinction of the dinosaurs left this massive, glaring gap in the global food chain. It created an opportunity for those small surviving mammals to evolve into horses, whales, primates, and eventually us, humans. In a weird way, we owe our existence to that asteroid. But today, the data shows that life on Earth faces a completely new threat.
Data from biologists indicates that we have already entered the sixth mass extinction event in Earth's history, commonly referred to as the Holocene extinction. But this time around, it's not a volcano and it's not a random asteroid from space. According to the source material, this ongoing loss of biodiversity is happening at 100 to 1,000 times the normal natural rate, and the reports show it is being driven by human activity, specifically habitat destruction, deforestation, and pollution. Thousands of species are currently listed as endangered or have already vanished entirely in recent years.
So how are global institutions responding to this? Well, they're actively attempting to halt this ecosystem collapse. Back in 2010, the UN set 20 specific biodiversity targets, but reports indicate most of those were missed. In response, a new Paris-style plan was drafted, setting a strict new deadline for 2030. The major goals outlined in this plan include protecting 30% of global land and oceans, reducing global pollution by at least 50%, and limiting the rate of extinctions to fewer than 20 species per year. Correcting these failures is absolutely vital because, as the fossil record clearly shows us, ecosystem collapse always takes the dominant species down with it.
Which brings us to this chart, and honestly, it is highly humbling. Dinosaurs were the dominant species on this planet for a staggering 174 million years. Humans, according to the data, have been here for a mere 300,000 years. Let that math play out. The dinosaurs ruled this Earth 600 times longer than we have even existed. So here is the big, provocative question I want to leave you with. Can humans actually beat the record set by the dinosaurs? Will our collective efforts to protect our planet's ecosystems secure our long-term survival? Or are we driving ourselves toward an incredibly early exit? Something to really think about. Thank you so much for joining me on this explainer. I really hope this sparked your curiosity and gave you a whole new perspective on our planet's epic history.